And I'm back. Next little section is over alternating and direct current. This is going to be a pretty short video, just a few handful of slides as we go through and look at them. But we're going to talk about the differences between these two different types of current, inspired the name of the epic rock band, in case you've ever seen that before. So we're going to ask what direct current, what is alternating current, what are some examples of each, where do we see them around us, kind of what are the advantages of each, and that literally is our vocabulary. It's just alternating and direct current. Direct current is what we worked on. If you've done this in the classroom with batteries and just hooking up some bulbs, that's direct current. So in direct current, the electrons are flowing in a single direction. Now, in both cases, what we're going to come up with here today, current is the movement of electrons. So we can get the electrons to move in a couple of different ways. So traditionally with a battery, again, we have a voltage difference with the battery so that the charges are built up on one end, and we connect one end to the other end with a wire. The other end doesn't really have any charge, so the electrons want to flow from the area of high potential to low potential. And we give them one path to flow through, and they flow through that path. So direct current flows directly from one end to the other. As this happens, the voltage and the current remain constant. So a 9-volt battery has a 9-volt current, 9 volts with it. Depending on what's attached to the wire, the current that's going through the wire is going to stay steady and constant and doesn't really change. Okay, so what we see is, I know the diagram on the left looks a little bit different than the one on the right, but on the left, when you have a battery, typically what we see is the electrons actually move from the negative to the positive terminal as the electron flows. So the one on the left, you can actually see that the circles are moving, and that's supposed to represent the electrons, and you'll just notice again, they're just filing one after another, one after another, one after another in a constant steady state. We can contrast this to alternating current, which you might be able to figure out by the word what happens with it. And so what happens with an alternating current is that the electrons are moving pretty much continually, but they're moving back and forth, almost like taking a giant saw across a tree and going back and forth, back and forth, back and forth, back and forth. And so the mechanism of this is a little bit different for us as consumers and users. We don't really notice it. But in the case of the alternating current, the voltage and current are continually changing. If you notice on the diagram below me on the video, you can see the little circles are moving back and forth, back and forth. So that means actually there's times when they stop altogether. The current is continually changing. It's going from 0 and maxing out in one direction and then going backwards in the other direction. And so there's a constant changing of the current. So things are a little bit different with an alternating current. And again, how does this occur? So in direct current, it's going to happen through a battery. Alternating current is what we have like with the power plant. And so since electrons have a negative charge, we can push them and pull them by exposing them to positives and negatives. And so if you are continually exposing them to a changing positive and negative, you're going to have this continual push-pull with them. And so the source of a power plant, that's effectively what's going on there, is that the chain or the wire that's generating the electricity is being exposed to constantly changing plus minus charges, which is causing kind of this zigzag back and forth with the electrons all the way into your house. And so it's a very different mechanism. But again, you do have the electrons moving through whatever it is that we're using, and that's going to be able to generate the electricity that we need to use whatever it is that we have, right? So again, very different kind of mechanism. So in effect, the frequency at which these things are moving back and forth is pretty high, say like 60 times a second. And what that means is, if you really think about it, if you look at the diagram, there's a moment like right now and now and now when really the electrons stop moving altogether, which means the electricity goes off. So the light bulbs around us, a lot of these lights, effectively, things are flickering like 60, 70 times a second. Our eyes don't even notice them because it's happening so quickly. So that's one of the weird things about alternating current, is that actually things that use alternating current are constantly turning on and off. But we often don't notice because of what's going on with it. Where do we use each of these? DC is going to be with anything that's got a battery. Now, we use a lot of things in our house that we plug into the wall, but they technically still have a battery, or they have some kind of an adapter that changes the uh, current coming from the wall into a direct current. So my laptop I'm looking at right now, it's not plugged into the wall. It's got a battery in it. So it's effectively using DC, but it plugs into the wall to be able to charge itself up. And we'll just see in just a second, that's where the alternating current is. So we use DC in a lot of different things with batteries, even if it's a rechargeable battery, fuel cells, solar panels, anything that's going to have a direct constant supply of electricity. Alternating current, when we plug something into the wall, that's alternating current. Again, a lot of the things that we actually use when we plug into the wall has some kind of device to it that changes that alternating current into a direct current, so that there is this slow, steady, constant electricity that's running through it. As you might think, a lot of electronics like computers and things probably don't really need electricity kind of zigzagging back and forth and having all these variations in the amount of current that's going in them. We do have devices that can change one to the other. The advantages of each, I mean, it sounds like we use DC a lot, and it is because it's constant, this constant steady voltage, which is really, really nice. But one of the problems of DC was solved by AC, that alternating current can be transmitted over long distances without really losing any power. DC can't do that. And in fact, some of the first power plants, when they tried to make DC current, they really could only send electricity for about a mile or so. And if you can imagine, if we needed a power plant every mile, that would kind of get cluttered around. So one of the things that alternating current allows us to do is to send power and send electricity over those big power lines over tens and dozens, hundreds of miles in a lot of cases. And the other thing that we can do with alternating current is use these things like down here in the bottom left-hand corner, which are transformers. So we have things that allow the voltage to go higher and the voltage to go lower. And that affects how well they're able to travel across the wires. Again, I'm not really an expert on how all this happens. But the big power lines that you see, they generally are high voltage lines. But when they get to your house, out somewhere near your property, even if you have underground ones, there's these transformers that take the high voltage and kind of step it down and cause it to go down to a low voltage before it comes into your house. And those are things that DC really can't do. And so that's one of the reasons why we tend to use AC, at least up until the point that it comes into our houses. Historically, once we started getting electrified, and I'm not going to spend a whole lot of time on this, but it's always kind of an interesting backdrop. A couple of the real famous scientist names that are involved with this in I think the early 1900s or the late 1800s was Nikola Tesla, and we know his name now through the cars. But Tesla was a real human being that engineered a ton of things and was a brilliant man, and had developed a lot of patents and inventions for alternating current. A lot of his inventions were acquired by the Westinghouse company and was developed afterwards. They were kind of competing with Thomas Edison, and Edison was, the inventor of the light bulb and had all of this stuff going for him. Was kind of a superstar, celebrity scientist, inventor at the time, and he had invested heavily in a lot of direct current and was in, direct financial competition with wanting direct current to be the way that people got things powered. Again, one of the drawbacks was you had to build a power plant every mile or so, and Tesla's concepts and inventions kind of solved the problem of being able to send power long distances without it kind of going away. A number of things happened over the course of this, but Edison tried to discredit Tesla, did things like showed how dangerous the alternating current was, because it is at a very high voltage. He did things like electrocute elephants to death, which was kind of a horrible thing to do. So Thomas Edison, not one of the greatest human beings in the world, but he did what he needed to do to try to build his business. Not very ethical. But in the long run, what happened was the alternating current eventually won out because of a number of reasons. Again, largely its advantages of being able to transmit the power across long distances. There was a movie that came out a few years ago called The Current War. It was actually a big time movie. It wasn't really just like a niche science movie. It was kind of all over the place. But if you're ever interested, check it out. So again, direct current is current that's going to travel in one direction only, whereas alternating current goes back and forth. They have different sources for that. Direct current's usually going to be with batteries. Alternating current's usually good things that we stick into the wall. There's some advantages and disadvantages. Direct current gives us a nice steady current, but the problem is it can't travel long distances very well. So alternating current comes into that. So fortunately, we've developed technologies to be able to change one to the other to take advantage of the advantages of each and make it nice and useful for our house. And that will do it.